Hello everybody and welcome to today's lesson on tessellations. Our objective for today is we will be able to identify tessellations. So first of all, what is a tessellation? A tessellation is a repeating pattern of figures that completely covers a plane without gaps or overlaps. Think about tiles on the floor. And in fact, why don't you just take a look at the floor in the room that you're sitting in right now, whether there are tiles on that floor, and note the shape. Or maybe another room in your home or when you're coming back to school. This pattern here on this page is actually a tessellation, and it is a regular tessellation, and it's called regular because it's made up of regular hexagons. Remember, regular means that the polygon has all congruent angles and all congruent sides. So see how we got a regular hexagon right here and another one right next to it. And a third one, and they all fit nice and snug into each other. Why does that work so nicely? It has something to do with their interior angles. So let's figure out what those interior angles are and take it from there. Remember, the sum of the interior angles of a polygon is equal to n minus 2 times 180. Here we have a hexagon, and hexagon means 6, remember. So n is equal to 6. 6 minus 2 times 180. 4 times 180 is equal to 720 degrees. But that is just the sum. We want to know how much the measurement of each one of these interior angles is. They are congruent, so one interior angle will be the angle sum divided by how many there are. We have 6 angles in the hexagon. That means the measurement is 120 degrees. So if I'm looking at this angle right here, that angle has a measurement of 120 degrees. And then there's another angle right here next to it that will then also have a measurement of 120 degrees, since it's a hexagon with the same size and same shape. And this angle up here also has 120 degrees. So if I look at this point where the three angles of our three hexagons meet, and I trace around where those angles are, I can make a full circle without any gaps. Saying it in different words, if we add the three angles together, what do we get for a sum? 120 plus 120 plus 120 is 360. 360 degrees is the measurement of a circle. So those three interior angles of our three hexagons together make up exactly the number of degrees that a circle needs. So there's no gap. Or if we take our 360 degrees and divide it by the measurement of one of our interior angles, we get exactly 3. That means we need exactly 3 of those interior angles to make up the 360 degrees of our circle. Now let's see if tessellations work with other types of regular polygons. Up here on top I have regular pentagons, so let's see if we can put these together to make a tessellation. Remember, they are not allowed to overlap or leave any gaps. So far so good. Putting these together, and one more. But now I have a gap here that I cannot cover. This one doesn't quite reach all the way in, or if I go any further to cover it, then I'm actually overlapping. So, and I did this before already here. So the answer is no. This does not work. For regular pentagons, a tessellation is not possible. So let's look at those angle measures and see what happened, why it doesn't work. A regular pentagon has an angle sum of 5 minus 2 times 180, which is 540. If that's our angle sum, then one interior angle will be 540 divided by 5, which is 108 degrees. So 360 divided by 108 gives us what number? And we can use a calculator for that. And we get 3.333 repeating. How about triangles? Can we put them together without gaps or overlaps? It looks pretty good to me here. And there is a tessellation of triangles. So triangles can be tessellated. What about squares? I am sure you have seen rooms with square tiles before. One of them is my classroom, right? So even without trying it out, we know that that works very well. And now let's see octagons. They look like they fit nicely together. But what about here? If we want to close this gap, we have to overlap. So octagons do not tessellate without gaps. But we can now go back to our notes and note down all the things that we just found together. Which of the following regular polygons tessellate? Our triangle we tried where n is equal to 3. We get 3 minus 2 times 180, which is of course 180. That is the angle sum of a triangle, which is the basis of this formula. Dividing 180 by 3, we get 60 degrees for each interior angle. And dividing 360 by the measure of one interior angle, we get 6. And that is why triangles tessellate. How about squares? We saw that n is equal to 4. 4 minus 2 times 180 is equal to 360. 360 divided by 4 is equal to 90. And now we already know if we take the 360, which is also the measurement of a circle, and divide it by the 90, we get 4. So the answer is yes. We saw our pentagon with n is equal to 5. 5 minus 2 times 180 is equal to 540. Then we took our 540, divided it by 5. That gives us an interior angle measurement of 108 degrees. 360 divided by 108 is 3.33 repeating. And this could not be tessellated. And last but not least, our octagon with n is equal to 8. 8 minus 2 times 180 is 1080. 1080 divided by 8 will give us an individual interior angle measurement of 135 degrees. 360 divided by 135 is 2.66 repeating, and no is the answer. So how do we ultimately find out if a regular polygon will tessellate? The interior angle measure must be a factor of 360 degrees. A factor means divide evenly without remainder. So 360 divided by the measurement of the interior angle has to be a whole number. Whole number. 6 is a whole number, and 4 is a whole number. And in the other examples, we did not get whole numbers. 3.3 repeating, 2.6 repeating are not whole numbers. Looking back at our hexagon from the beginning, 360 divided by 120 is equal to 3. That's a whole number. Now, tessellations are also used in a variety of artwork, and the Dutch painter M.C. Escher is one of the most famous artists that used tessellations in his artwork. Here are two of his paintings. Identify the figure that is tessellated in the following images by M.C. Escher. On the left, what do we see here? Some of these are white, some of these are black, but it looks pretty much to me that they are birds. What do you guys think? And the one on the right is interesting because here he actually used two different type of objects. First of all, we see fish in white, and then the object in black looks maybe like a boat. Could be something like a boat, or again, maybe you see something else there. But these are examples of how tessellations can be used in artwork. And again, remember, each object fits perfectly into the other without gaps or overlaps. For the last example of this lesson, we have a tessellation of fish-shaped polygons in here, and some of the angle measures of the fish are given, and we are supposed to find x. So the important piece here is to recognize that we are talking about a tessellation, and that means that the objects have the same size and shape, and even though we don't know the angle measurements of the white fish, for example, they have to be the same as the angle measurements of the gray fish. And furthermore, as you can see, there are many lines that are being formed, and some of those lines create angles that we know from previous lessons. If we look at this line, for example, we know if this is a straight line that this entire angle has to be 180 degrees. That means these two angles are forming a linear pair, and together they form an angle of 180 degrees. And from looking at our gray fish, we know that our obtuse angle has to be 150 degrees. The obtuse angle in the right fish is 150 degrees, the same as the one in the gray fish. So to find x, we just take 180 degrees minus 150 degrees, which is 30 degrees. So x is equal to 30 degrees. For your summary, I want you to describe a tessellation that you have seen anywhere. What shape or even shapes created that tessellation, and is it regular? So much for today, and I will see you in class.